Hi there, I am Alejandro Lopez, Application Engineer at nTopology, and in today's nTop Live, we're going to discuss how you can improve your topology optimization in nTop, even if it comes from a third external software, or if you do your topology optimization in nTop. But we're going to see how we can do things such as increasing the thickness of thin elements automatically, how we can smoothen the part and put it back to CAD, also round more sharp corners. We're going to see all of that today. So I hope you find it interesting. And before getting started, I'd like to thank Ankush Sharma for this nice bell crank part that I'm going to use in today's nTop Live. So let's get started. All right, so starting from this part, this nice topology optimization result, if you got to this point and you still feel like there's a few regions that are a bit too thin, like for example over here, what you can do is bring this to nTop as a mesh or as a set of points, and you can put that into implicit, and then we can smoothen that part, and we can measure the thickness with this custom block that we have created. You specify an amount of points that you would want to place over the whole part. And each one of these points will actually shoot a ray that is normal to the surface, both in the interior and exterior of the part, and this will determine the part thickness. And then when you have all these points that are measuring the thickness everywhere, you can actually create a thickness map out of it. And with this thickness map, what you are going to do, you are going to be able to thicken the part in the low thickness regions. So this is the part before the thickening and the part right after the thickening. And if you look closely, here where we have a lower thickness, we increased the leg here, the thickness of this leg. But here, where we didn't have a low thickness value, we didn't touch the part at all. And all of this is based on some input parameters that I specify here. For example, I specified that any region that is 1 millimeter of thickness or less is what I consider a thick part that needs to be thickened 1 millimeter extra. And then what I consider a thick part is the regions where I have at least 12 millimeters of thickness. If we look at our part, we see that we have up to 65 millimeters of thickness in some regions. So any region of 12 millimeters and above will not be thickened. And all the other regions that are below 12 and up to 1 will be thickened. And you might say that this looks a bit rough, and that's true. That's because of the discretization of the 400 points that we used. We don't have a perfectly continuous field, but that is not a problem because in our workflow of going back to mesh and then quadrangulate the mesh and then going back to CAD, we round the part again. And now if we compare the final part with the initial part here, we see that all those struts here have been thickened effectively. So, and then we see that those struts that were not that thin have not been thickened. Okay. And then if I want to go ahead and change some parameter, for example, if I want to change this bell crank lever to something like thickening, let's say 2 millimeters instead of 1, all we need to do is to change that parameter, and soon we will get the new part on the screen. So right now, all the meshes have been recomputed, and we can see already that we have a much thicker part everywhere. And forgot to mention this, but I also added in this workflow a added weight block that will tell you how much weight you're adding back to the part because of this operation. So we are quadrangulating the mesh right now. And once that happens, the phase consolidation will recompute in this block. And then we'll get the new part on the screen and also the added weight percentage. All right, so here's our part. We can see it's much thicker than before. And we have added 86% of weight with respect to the original part. If I go back to the previous design, you can see it's much thinner. And previously we had only added 36% of weight. Okay, so with this workflow, you can get a nice fast way to modify your topology optimization to avoid having such thin regions. And of course, get information of how much weight penalty you're adding because of this operation. All right, so this is the first example I wanted to show. And I have a second one with the classic General Electric bracket. So we see that there's a bunch of thin regions over here. So we did something similar to this part. We threw a bunch of points on it and created a thickness field from it. Okay. And we thickened the part based on those values. All right, so here it is. So if I compare this part with the initial part, we see how those thin struts have been thickened. Okay. And again, we face the problem of the roughness, but that will not be a problem, as we will see later. But what I wanted to say is I actually added a few more things to this workflow. I added the capability of refilleting the part. Some people out there, they don't like very sharp corners. And what I did here is I added a few regions, those 3 points that we see on the screen, where I want to redo the radius so that it's larger. So what we did here, I have a block that you can download later and use it as well, that allows you to basically refillet the part. So if we go to the original part, you see we had these small radiuses over here. When we refillet it, based on the points that I placed, we get larger corners, which will allow you to have less stress concentration. And that's what we see in this final part in the end. Not only we have thickened the thin struts, but also we have improved some of the radiuses of this part, as you can see. And all of this in an automated workflow that you can use on any part all the time. Okay. And then the final step here is I exported this part, to which I only added 14% of weight, which is not bad because I improved a lot the part quality, everything's smooth, and I don't have too thin regions anymore. And I was able to bring this into CATIA. So originally, this is what I brought. And many of you might be wondering, okay, this is all great, but I'm losing the functional interfaces of my part. That is not a problem. You can, typically when you have the topology optimization, you're also going to have the design space. So in this case, what I did is in CATIA, I selected a few of these functional surfaces, I thickened them, and then with a few easy Boolean operations, I was able to obtain my topology optimization with perfectly functional interfaces everywhere, including here. All right, so that's all I wanted to show today. I hope you found that interesting. Please write us if you have any questions about this workflow. You have my email address here. You can personally address me if you want, and I'm happy to answer to any questions you might have, or even do a personalized demo if you want of this workflow or any other workflows that you find in our website. So if you go to nTopology.com and you go to resources and videos, you will find many other nTop lives and other videos with lots of applications that we deliver to you every week. And every time you can go ahead and download the workflow in case there's any files for download. Okay, so it will be the case for what we showed today. You will be able to download the files and explore all of the things I explained by yourself. So thank you again for your time and have a nice day.